Good morning. I'm Dr. E. Kavita, working as Assistant Professor in the Department of Chemical Engineering, SRM Institute of Science and Technology. I welcome you all for the experiment Determination of Emissivity. There are three modes of heat transfer. They are conduction, convection, radiation. Conduction is the actual but invisible movement of molecules through a continuous substance due to temperature gradient. Whenever there is a temperature difference between surface and fluid, heat is transferred by convection. Radiation is the transfer of heat by electromagnetic waves and it does not require any medium. What happens when incident radiation falls on the surface? When incident radiation falls over the surface, part of the energy is absorbed, part of the energy is transmitted, and part of the energy is reflected. Now let us see what is the theory involved or what are the theories involved in radiation heat transfer. Black body is an important concept of radiation. Black body is an ideal body that absorbs all the incident radiation and it does not transmit or reflect the energy. It is a perfect emitter and the total energy, that is the radiation energy emitted by the black surface, is a function of temperature only. In actual case, the real surfaces encountered in engineering applications do not behave like black body. So the radiation characteristics of real surface can be compared with the ideal concept, that is black body. How do we calculate how much energy emitted or radiated by the surface? In heat transfer applications, rate of heat transfer and heat flux are generally used for the calculation of how much energy transferred. In radiation, we use a term called emissive power. Emissive power of black surface can be calculated by Stefan-Boltzmann law. So what does it state? Stefan-Boltzmann law states that emissive power of black surface is proportional to fourth power of absolute temperature. But how do we calculate emissive power of real surface? There is a factor called emissivity. With the help of that, we can able to find out the emissive power of real surface. So what is that emissivity? Emissivity of surface is a measure of how the surface emits radiation energy in comparison with the black surface at a particular temperature. So emissivity is defined as the ratio between emissive power of real surface and emissive power of black surface at the same temperature. So what is the aim of the experiment? To determine the emissivity of a given non-black surface. Now let us move on to the description about the experimental device. The experimental device consists of a chamber, which is an enclosed chamber. Inside the chamber, we have two aluminum discs of equal size. The diameter of the disc are 150 mm and the thickness is 7 mm. One of the discs is a black surface and another disc is a non-black surface. We are interested in finding emissivity of the non-black surface. This chamber arrangement is connected with a heater. From heater, this chamber receives the heat energy and it is transferred to aluminum disc and the black surface. And from there, we can able to go for the observations and the calculations for finding emissivity of non-black surface. And there are thermocouples over the black surface and also non-black surface at equal angle. And there are thermocouples to measure the chamber temperature and also ambient air temperature. And the heat input to heater can be regulated with the help of voltmeter and ammeter. And there is a digital temperature indicator to display the temperature. Now let us see how to perform the experiment. That is procedure to do the experiment. So this is a schematic representation of experimental setup. So first we need to switch on the main, then regulate the power input by adjusting the thermostat knob, and note down the power input by noting down voltmeter and ammeter reading. The next major observation is temperature. So note down the temperature across the two discs, that is black surface and also non-black surface, then chamber temperature and air temperature at 5-minute time interval until the system reaches steady state. How do we identify the system has reached steady state or not? Once the system reaches steady state, net rate of heat transfer becomes zero and you will get constant set of temperature data. Once you arrive at constant set of temperature data, you can start performing the experiment. Next, we'll move on to observation, how to tabulate the experimental data. So first you need to note down voltmeter and ammeter reading. So V refers voltmeter reading and I refers ammeter reading. Next, tabulate all the temperature data. So T1 to T3 refers test surface temperature, T4 to T6 refer black surface temperature, T8 refers chamber temperature, and T7 refers room temperature. As I mentioned earlier, all the temperature data to be noted down at 5-minute time interval until you get constant set of temperature data like this. Once you arrive at these kind of temperature data, you can start performing the experiment. Then let us see how to do the calculations. So the rate of heat input to heater is calculated by using the formula Q is equal to V into I, where Q is the rate of heat input, V is voltmeter reading and I is the ammeter reading. Using voltmeter and ammeter reading, you can calculate rate of heat input to heater. The next step of calculation, emissivity. So emissivity is given by the formula TB to the power 4 minus TA to the power 4 divided by TS to the power 4 minus TA to the power 4. So what is TB? So TB is the average surface temperature of black surface, which can be calculated by taking the average between T4 and T6. Then TS is the average surface temperature of non-black surface, which can be calculated by taking average between T1 and T3. And TA is the ambient temperature. So this can be calculated by taking the average between chamber temperature and room temperature. That is, by taking the average between T7 and T8, TA can be calculated. By substituting all the temperature data, you will get emissivity of non-black surface. Then final step, tabulating the result. So the emissivity of the non-black surface can be reported as the result of the experiment. Thank you all for listening. Thank you.